My name's Michael Lucas, and several years ago I decided I would write a book on jails, and that's when everything went horribly wrong. I wound up writing 7 books to learn enough to write about jails before I could write about jails. So, let's talk about jails. How many of you were sysadmins before virtualization? Most of the room, excellent. You remember how you got a new computer or a new server, and OS installs were important. Perhaps your company had 1 or 2 servers in the office, and figuring out how to install them properly to meet all possible future use cases took quite a bit of time before you even put the first install floppy in. And virtualization kind of changed that. All of a sudden, OS installs were trivial. You installed a VM, you installed an OS. If you didn't like it, you threw it away. And jails are one of the earliest virtualization systems of the modern era. There's something called a lightweight virtual machine, where the user-land virtualization relies on the host kernel for services. And they have been called a chroot on steroids. That's not exactly wrong, but it's not entirely correct. A jail is a collection of namespace transformations. When you have a process running inside a jail, all of its affected namespaces are changed in some way. File system is changed much like a chroot. Process IDs are changed in a way that the host's processes are filtered out from what the jailed process can perceive. The jailed process perceives only a subset of process IDs running on the system, and that subset is processes contained within the same jail. IP addresses. A jail sees only those IP addresses permitted by the host. And usernames. A jail has its own Etsy password and draws its usernames from there. Root inside a jail is not the same as root on the host. You can think of a jail as a literal jail cell with a one-way mirror. The warden can walk around and peer in all the jail cells and do whatever he wants, but the inmates cannot peek out. Now, one of the things about jails is people will argue about the security. We're sysadmins, we love to argue this stuff. At times, I think that's merely an excuse to drink beer. But there is this fervent argument over are jails secure versus are they not secure. And the truth is, this has a really, really easy answer. How many operating systems does your computer run? And if you think about it a moment, your RAID controller has a firmware, it has a little menu that it goes into, and it interprets hard drives for you. That's an OS. The hard drives themselves. Rod Grimes, if you get him talking, will go on about how he'll hook up power to a hard drive that's disconnected from a computer, take a couple alligator clips to some of the pins, and connect those to a null modem cable, and he gets a little menu that's for firmware that's running on the hard drive. If it provides a menu, it's an operating system. CPUs run their own firmware, and we have seen that firmware attacked for years. I mean, Colin back in 2005 wrote a paper on that, and it didn't have any name or any branding because we were too busy breaking the internet back then to market ourselves. Motherboards have firmware, and some vendors have experienced attacks that way. So basically, operating systems that we run, it's turtles all the way down. So would I use jails in a secure environment? What does secure environment even mean? If your standard for security is something like it's a non-flammable environment with redundant power and controlled physical access, sure. If your idea of secure environment is, would I put a web GUI in this to launch nuclear missiles? Well, no. That also avoids the other question of, would I put a web GUI to launch nuclear missiles anywhere? And the answer there is no. So you need to decide, what does a secure environment mean for your work? What problem are you solving? And jails can be useful, even aside from the security aspect. They can be very useful to constrain software to a particular specific environment. Now, all of this about namespace transformations sounds simple, but the actual practice is very complicated. With jails today, you can leverage ZFS. You can leverage virtual networking. You can use all of these tools. But the problem is, to use these tools, you have to understand them first. I've gotten complaints that my new book on jails is very advanced. And you know what? Yes, it is. If you want to use ZFS, you have to understand ZFS. If a /27 net mask makes you kind of whimper and cry, you need to learn networking before you set up your virtual network. If you don't know why a virtual bridge isn't really a bridge, you need to go back and learn some other things before you can leverage them in jails. And jails are in some way the apex of system administration. So, and jails are not a new thing. The earliest jail-like code appeared between 18 July 1975 and the 7 May 1979 Unix snapshots. This is a known idea. Paul Henning Kamp came up with modern jails in '98, and they've developed rapidly since. And there's been a problem with this rapid development in that originally, jails had a very limited feature set, and people would ask, can I do this? And the answer was no. And then, because we're clever, someone came up with a workaround to make such a feature work. And then someone else would say, oh, that workaround is terrible. Fine, I'll invent an official way to do it that's less awful. And then years or a decade later, someone else would come along and say, oh, the official way is terrible. Here's a better official way. And if you go browsing the web for tutorials and instructions and answers, you will wander down many strange and terrible rabbit holes. People have done horrible things to make jails work. And so when you go looking around, you have to pay close attention to the dates. Posts from 2005 are probably wrong, exactly like trying to use today's documentation in the year 2035 would be wrong. So let's talk about the jail host quick. Your OS on the bare metal is important. I would tell you that you have to live with these decisions as long as you have jails running on your host. And a lot of common sysadmin practice really holds true here. Separate your OS storage from your jail storage. Memory, I can't really tell you how much memory you need because it all depends on what your jails are going to do. But in short, you need all of it. Processors, again, The FreeBSD scheduler does a pretty good job of balancing processor load between CPUs, but put 500 jails on the host and you want all the processor. IP addresses, assign one address for the exclusive use of the host, preferably on a separate network card. Because if one of your jails goes insane and starts saturating the network, you want to be able to connect to the host and terminate that jail. Also, any networking on the host supersedes networking on jails. So all of the services running on the host should be bound to that single management IP. For example, SSHD defaults to binding to all IPs on the host. And if the host's SSHD is listening on a jail IP address, that means you can't run SSHD on the jail on port 22. And statements like, the hosts run SSHD on port 22, but jails run SSHD on port 23. This gets a bunch of users at your door with torches and pitchfork. Lock all of these services down and secure the host as best you know how. Once you have a host, you can actually start to configure some jails. Jail configuration is done through a bunch of parameters that look a lot like sysctls. IP4 adder is an address. Allow mount. Can this jail mount something? Some of these are Boolean, and they change the jail just by their presence, kind of like when Darth Vader walks into the room. Others are something that you set, and all of these are set in etcjail.conf. So here's a base entry for a simple jail. You have to define a host name, an IP address for this jail to use, a path to the jail files, and here we're turning on a device file system. The exec clean tells the jail to start with a clean environment. Don't inherit anything from the parent process. Because if I start a jail at the command line, I don't want it inheriting like my SSH authsock or xterm or any of this stuff I may have. And then we define some shell scripts to run at jail startup and shutdown. A lot of this is common across jails, so jails can have default settings. Here I've defined 4 defaults. Every jail gets a device file system, starts up clean, startup and shutdown scripts. And then the jails themselves only need to define what is specific to that jail. And each jail can then override the default settings. You'll see that our first jail on the lower left, log host, we set a host name, IP address, and a path. The MariaDB jail on the right also defines exec start because whoever set up this jail thinks they can do a better job of writing system startup scripts than 40 years of BSD developers. And you can guess how well that usually comes out. Jails also do variables, and variables are where jail configuration gets very nice. Here I've defined a cache-j variable for the file system path /jail, and path, the next one, goes under cache-j cache name, where cache name is the name of the jail. And the host name is based on the name of the jail. And the last setting there at the bottom, IP host name, that says, look up this jail's IP address in DNS and assign that IP to the jail. So our individual jail entries turn into, up at the top right, the jail log host is now just a name and a couple brackets. The jail MariaDB, well, it's very obvious what the overrides are for this jail. because each of the individual definitions are so nice and small. So we have this directory where the jail is supposed to be locked into. What goes in there? Really, it's just the base TXZ of any FreeBSD 4 or newer. So you can go back almost 20 years. You do have to add a couple things to this. You do want to add a user. You want to set up resolve.conf. You'll want to touch the FS tab. A surprising amount of software goes nuts if your host if the machine it's running on doesn't have etc FS tab. It doesn't care what's in it, just that the file should exist. The key here is ELF. Anyone run a system with A-out binaries? Yes, of course, Mr. Baldwin back there, but you can compile a custom kernel and run even older FreeBSD, but we dropped A-out support back in, ask John Baldwin again, he'll know. And yes, some of you probably remember that 4.0 used TGZ files, not TXZ, and all of you are welcome to shush anytime you want. So, one key is the jail must be the same version or lower than the host. You cannot run a FreeBSD 13 jail on a FreeBSD 12 host. So, once you have a file system, you start the jail. And we just run either service jail start and the jail name, or you can use jexec to say start this particular jail. And technically, both of these are front ends to the JL8 command. And why would the base system use a front end? Well, because the command line looks something like this. I may be kind of old school, but I'm not typing that. If you're running multiple jails and each one has a service inside it, for example, I have a web server and a database server, I want to be sure that they start up in the correct order. There is a jail parameter for that. So you can dictate what order they start and stop in. And once you have a bunch of jails, the JLS command shows you what they are and what's running. And while that is useful, where JLS really comes in useful is it lets you look at existing jails and say what they're running at, what settings are they using at the moment, why is this jail behaving badly? And you can dig into the parameters and find out what's going on. And that's great for a specific jail. But often what you're worried about is a specific parameter across all the jails. And JLS lets you grab those parameters and presents them in a table. Now, if you're on the host and you run PS, you're going to see all of the processes on the host and all of the jails. And in a on the host, this J flag to PS indicates a jailed process. All of these here, if you start an empty jail, you're going to get syslog D and cron, just by default. So all of these are running inside jails. You can also use the -J flag and name a jail and see what's running in that particular jail. All of the process-related commands like pgrep, pkill, top, except this -J flag. Fortunately, somehow it was free across all of these commands. We were very lucky there. Now, a jailed process is sort of running in a special context. And you, sitting on the host, can start a new process and stick it inside that jail's context. These processes don't have to be children of the initial jail process. So here I'm simulating a root login in a jail from the host. And we use this -L flag to purge my environment again, so I don't get my SSH settings or whatever inside the jail. Jails have a lot of other settings that let you glue stuff together. Here, I'm using the pre-start and post-start commands to run commands on, pre-start and post-start parameters to run commands on the host when the jail is about to start, after it started, when it's about to shut down, and after it shuts down. And while I'm just using logger statements here, you can use this to provide all kinds of glue to give jails the special settings or features that you want them to have. And there's also a console log, so you can see what happened in the jail during startup. Package management in jail has one major choice you have to make. Package works on the host for managing packages inside all the jails, or you can manage packages actually from inside the jail. So no matter which one you choose, the package database for a jail is inside that jail. I would tell you to choose one method and stick with it, simply because things go wrong, and it is possible for things to be subtly different, say inside your FreeBSD 10 jail versus your FreeBSD 13 host, and you don't want to see some subtle difference in the package tools messing things up. Choose one method, stick with it. So that's really the basics of jails. And here is where most of us go horribly wrong. Having many copies of the same userland for a jail just feels sloppy. You know, if you have 500 jails that are all running FreeBSD 12.0, patch level 7 or wherever we are, do you really want 500 copies of the same userland for that many jails? And it seems we should be able to reuse the same userland across multiple jails. There's lots of solutions for this. And people for years have fought for this. And it can be done. But I would tell you today that disk space is cheap. And the FreeBSD base install is small. And when it comes to jails, file system optimization is directly proportional to downtime. Because when something goes wrong, you have to sort out what you did and exactly what happened and how did this work and how does this really behave. And then you get to yell at 6 months ago you for trying to be clever. So let's talk about how to be clever. Cloning with ZFS. You take a snapshot, set up a clone, use it as your base data set for the jail. Yes, you have to change the SSH host keys and password and whatnot. And this is not bad. Your initial jail starts off as a duplicate of another jail. But over time, clones grow in size. If you have 500 jails running on your 1 terabyte disk, and over time, with each patch and each change you make, the size of each of these clones grows, and you may very easily run out of space. So you have to watch that. And a clone source with a bunch of stuff already installed is usually called a template. And IOCage does this slightly different. But base jails, this seems to be the holy grail. Literally one user land with many jails. And you use null mounts to provide basic user land for all of the jails. And then you give each jail its own fstab file. And you wind up with a jail configuration like this. The jail LDAP3 has an IP address, and we define mount.fstab as being this. And the fstab for your jail, it's going to be fairly sizable, but it gives you all of these directories, and in theory, you upgrade the base, and those upgrades immediately appear in all of the jails. And so theoretically, everything is in sync, except for packages. You need a unique user local for each combination of packages. So suppose you've got a jail with FreeBSD 12 and it's running PHP 7.2. And you have another FreeBSD 12 jail and it's using PHP 5.6. PHP 5.6 is end of life by a few months now, and I desperately hope to have time to stop using it sometime soon. And so I'd have to go in and swap each individual jail one by one as I move it from PHP 5.6 to 7.2. And some of those jails are going to need slightly different PHP additional packages. And those have changed between the two PHP versions. So you may be better off giving each base jail its own user local and just live with it. But this is a case of choose your pain. So another interesting feature with jails is that additional features have grown over the years. Some things that were impossible early on became grossly configurable and then finally configurable. And it really is that something that was unthinkable with 128 meg is trivial with 32 gig of RAM. I remember recompiling kernels to save 5 or 6 megabytes of memory because we desperately needed it. And today, that's just not a thing. The kids have it so good. But an example, my go-to example is System 5 IPC. This is a kernel feature that is just expected to be universally available now. But when jails first came out, all of the jails shared the same System 5 IPv space on the host. And theoretically, you could leak information from one jail to another through System 5 IPC. And then they added a feature to turn Sys5 IPC on and off globally and just say, no, we're not even going to permit that memory leak, stop it dead. And now you can configure all of the System 5 IPC features on a per feature basis. You can share them with the host. You can disable, fine-tune it all through different parameters. So if you're looking to do something, take a look, see if that parameter exists. You can also delegate file system management to jails. LSVFS displays jail-safe file system. Now, it doesn't mean that you can't run a jail on a file system that is not jail-safe. For example, UFS is not jail-safe. You can run UFS under your jail just fine. What you can't do is let the jail manage UFS because UFS has fingers all through the virtual memory stack, and it is not meant to be subdivided like that. ZFS was designed from the ground up to be manageable. So that is jail safe. And The host has specific parameters for each jail-safe file system to say which jails can mount what. So, jail networking. This has a few rules. One IP can be bound to one and only one jail. The exception being if the host has only one IP and all the jails bind to that. So jails can have multiple IP addresses, but they each have to be tied to a specific jail. Now, jails can only do basic TCP/IP networking. They can open ports. This means things like you cannot ping, you can't use SCTP or some of these other network protocols. If you want to truly open up networking for this jail, you have to set the allow socket AF parameter. AF means AF INET. I know those two letters have taken on different meaning these days, and that's not it. And all of this works great until the local host address. 127.0.0.1 or ::1. Every host needs a loopback address. This is core in Unix. And if you try to run a Unix install without a loopback, you get some really interesting failures. So, the rule about binding to one and only one address or one and only one jail holds. The kernel lies. It tells the jail that the publicly available address is the loopback address. So if you are binding daemons to 127.0.0.1 in the jail, you're binding them to the external IP. This is easily worked around. You just have to be aware of it. Now you can create additional IP addresses on the loopback, 127.0.0.2, 0.0.3, etc., and assign them to jails, and that's fine. But it's also, these days, it's a little more complicated than you have to be. FreeBSD has this thing called VNet. It's default in 12.0 and newer. It lets you set up a virtual networking stack inside each jail. So each jail has its own loopback. It has its own legitimate 127.0.0.1. Jails using VNet can run their own firewalls. They can do routing. I have set up a little farm of web servers in jails that all route to another jail that's using PF and routing and providing filtering for all those jails, and tied that to an external NIC, and there is my simulated server farm. So this is very useful. Now, you'll see a lot of stuff on the internet that says VNet is buggy. Well, the VNet project is very large and very difficult. It started in 2006. And yes, in 2006, it was very buggy. It took 15 years to beat the bugs out of this. So today it is solid enough that your host's network stack runs in something called VNet 0. It's just another virtual networking stack. You are already running VNet if you are using the generic kernel. So there can be bugs, file bug reports, but most of the problems have been beaten out of it. So let's talk about some weird things you can do with jails. You can have a jail that can run its own jails and set limits on them. So if your rule is that the databases must all be run in jails and your database development team keeps asking you to configure new jails for them with different settings, just set them up a jail that can run other jails and say, here, configure them yourself, tell me when you're done what you need. You can jail old servers. At one point, at the very last company I worked at, we had a mission-critical system running FreeBSD 4.9 or 4.10 with like PHP 2 and MySQL 3 running on a repurposed desktop machine. And we could not afford to lose this host. And in theory, if this machine died, I was supposed to take the physically identical machine and restore onto it, and I found this prospect terrifying. So I tarred up the old machine, I copied it into a jail on a FreeBSD 10 host, I got rid of a bunch of stuff, like you don't need SSHD, you don't need a firewall. I stripped it down to just these bare essentials, and it ran, and there was much rejoicing. So you can also install Linux in a jail. And people use this for porting software to FreeBSD. People have done device driver development in Linux jails. So that sounds strange, but it is surprisingly useful in circumstances that you don't want to find yourself in. Another useful thing is resource limits. You can control how much resources a jail can get. You say, you have half a CPU, or you're dedicated this CPU, or you get so much I/O, all of this, all these things that can make jails run amok. I find it useful, if nothing else, to say this CPU core is dedicated to the host, and the rest of the cores may be shared among jails. And this way, if something happens and one of my jails runs amok and starts eating CPU, I still have my dedicated network card and a dedicated CPU core, so I can SSH into the host, find the offender, and shoot it in the head. And there are also lots of interesting resource limits you can impose just in general with RCTL. When I first started playing with this, I set a limit that said PID1 may only run for 30 seconds of wall clock time. And it worked. And then I had to boot into single user mode to turn it off. But it did work. PID1 shut down in 30 seconds. Another thing I find very useful is if a jail is a collection of namespace transformations, what happens if you don't transform all of the namespaces? For example, network stack. You can tell the jails to inherit the host's network stack, which seems kind of odd, but if you're on one of those virtual machines out in the cloud and you have one public IP, and you want to jail your database and your web server and your mail server, traditionally people have set up firewalls and NAT and redirect to IPs bound to the loopback. But why? If this jail only has a web server in it and you're managing it entirely from the host, and there's only one address, let that one jail bind to port 80 and 443. That's its job. Ditto for any other public-facing services. Sorry? Yeah. Yes. If you start SSH in a jail, it won't work because the host is already there. And if you turn off SSH on the host, well, you'd be logging into the VM provider's console anyway. So, trimming a userland. How many of you have built a manual CH root with it? The bare minimum number of libraries and this exquisitely tiny environment where there's nothing to exploit. You can do that in a jail. It's a useful learning exercise. I would encourage everybody to do it once, just to see how everything fits together. Another thing you could do is give a jail access to the whole file system, which this is another of those things that seem counterintuitive, but what problem are you trying to solve? If you say you're running a big Postgres server and you have 4,000 students beating on this thing, and you want to control what resources they can access, and you want to be sure you save a little CPU for things other than Postgres in case things go bad, running it in that kind of jail may be a good solution. Just keep thinking, what is the real problem you want to solve? And this lets you emulate something like C groups. So, question?
Just a comment. It's also the complete file system. It's actually, that helped me develop the jail beehive. I was able to develop sysctl causals by test them out by.
Okay, for those at home, the jailed full file system helped develop Beehive and jailed that. So I'm going to give a couple words about IOCage in my last 2 minutes. IOCage puts a pretty command line on top of all this. It lets you essentially configure and manage jails entirely from the command line. And one reason I really like it is because of plugins. Plugins are set to go square up against Docker. I can run an IOCage command and install something like Elasticsearch or Plex. I use an IOCage plugin to manage my unified devices at home. And it simplifies a lot of services. How many of you have set up Elasticsearch manually? And how many of you would like to never do that again? Okay, why are there more hands for the second question than the first? So plugins automate a whole bunch of stuff like that. So we have 1 minute and 3 seconds for questions and answers. Let's start with Dexter.
What's the RCTL overhead?
I have seen conflicting things on RCTL overhead. So I have never had a problem with it. And there are people who have had problem with it. I am not going to say that, I'm not going to dismiss anyone's claims of having trouble. I will say, to keep filing bug reports, RCTL was turned on by default in 12, and over time I expect it to drop. Yes, sir? Why have we not abused jails to create C groups and run everything inside, every single service inside a jail? Patches exist for that. Nobody has picked them up. That's an initially very attractive idea. I suspect it needs a lot of discussion about unintended side effects, and that discussion has not taken place. I would encourage you to pick up those patches and have that discussion. Yes, sir? Yes, that's a hierarchical jail. Yes, sir? Well, you know, hang on. This is a civilization, and civilizations have rules. This is questions and answers. And if you do not want to provide the question, then I must. No, sir. We have rules. So here for you is my question. What is your comment?
I was just wanting to let everybody know that you can run carp with jails, and it is fully available to run, and it's one of the most useful things I use.
Okay, the comment is carp works with jails. And yes, that's very cool. I assume with VNet. Yes, with VNet. Okay. Any other questions?
Do you think jails and Beehive will converge to where there's no more separate use cases?
Well, will jails and Beehive converge? One is heavyweight full virtualization, one is lightweight. They have different use cases for different things.
And do you think that will continue?
I think that there will always be a need for both. And I think that if people have a use case that specifically calls for Beehive, they will tend to use Beehive. If people have a use case, if jails match all of their use cases, they'll use jails. Anything else? It's the end of the day. Your questions are keeping your fellow attendees from the bar. So, no, okay, I will be around. Feel free to ask questions, and thank you for staying until the bitter end.